Hi guys, so today we're going to have a look at an introduction to planes and a couple of properties of planes. So hopefully you've heard the term plane before. It's a flat surface that extends forever and has zero thickness. Okay, so that's the definition of a plane. And we can also think about vectors and planes together. We're going to do that. So a vector is parallel to a plane if by traveling along the vector you remain on the plane. Okay, so if you've got a plane that goes on forever, we know what a vector is. If that vector is always on the plane, we say the vector is parallel to the plane. Okay, if it ever leaves the plane, it will not be parallel. So you can see down the bottom here we've got an image. What looks like a sheet of paper, that's what we're looking at in terms of a plane. Now this thing goes on forever, but we've drawn in some boundaries there just to show you what it looks like, a sheet with its zero thickness. We've got a vector here going along the plane, and we've got this n vector coming out of the plane at right angles. All right, so we're going to have a talk about all of these things today. So we are going to use an equation to describe this, to describe a plane, and there's several ways to do this. We're going to use the Cartesian equation to describe the plane. So if we have a plane like we have down in the bottom corner with n, which we're going to call a normal vector. Okay, normal means at right angles to. So normal vector n with vector coordinates a, b, and c, and it also passes through some point x, y, z. Okay, you can see that here. Then this plane has an equation a, so that was the normal a, x. All right, that's just our constant x, so ax plus by plus cz. All right, cz, not cx like I wrote, so I've just changed that. And what that equals is a constant number, and that constant is going to be that a times by that x coordinate plus that b times the y plus that c times that z. Okay, and we can also call this d when we add these together, because this is just going to be a number plus a number plus a number. When you add those together, they're just going to equal d. So d is a constant. And this is the Cartesian equation of a plane, and this is what we're going to be using to describe planes. So just to delve into the normal of a plane. So a vector is normal to a plane if it's perpendicular to all vectors parallel to the plane. Okay, so no matter what we draw on this plane down the bottom, no matter what we draw, if it's on the plane, this n is going to be perpendicular to any of those. Okay, so if we think about this plane as like a tabletop, it means our normal vector is coming straight out of it, straight up, and any direction you go on the tabletop is going to be at right angles to that. And just as an intro, we're going to finish with one more formula. So the distance between a point and a plane, so we've got a point in space and then a plane. The shortest distance between those, if we're given a plane ax plus by plus cz plus d equals 0, so that's in Cartesian form, and a point in space we'll call x1, y1, z1. The shortest distance between these points is a x1 plus b y1 plus c z1 plus d, right? So the absolute value of that number, so you can't have a negative, over the square root of a squared plus b squared plus c squared. Okay, so this is a formula. We'll have a look at how to use this in the next couple of videos, but I just wanted to introduce it now. Okay, thank you.